Hello students, we are continuing our review on chapter 1. This is part 2 where we are going to discuss about the Venn diagram and operations on sets. Here you go. So Venn diagrams, the diagrams which are used for representing sets are known as Venn diagram, and usually we use circles for set and the rectangle for representing a universal set. For example, we see that here it is set A with 3 elements 1 to 3 and set U with all the 5 elements 1 2 3 4 5. So what we see, it can be represented in this way, where this is the rectangle and this is the circle actually. So this is how we represent a set, an universal set in Venn diagram. Next comes the operations on sets. The first one is union, second is intersection, difference and complement. So these are the 4 operations basically they are in your syllabus of class 11. And union means, what does it mean basically? A or B. So that is A union, which is equal to A union B. And how it is defined? It is set X such that X belong to A or X belong to B. So this is the definition of union of set. And in Venn diagram, union is represented by, if this is A and B, then this shaded region, this entire shaded region will represent as A union B. Next comes the intersection. Intersection means A and B. A and B intersection. So that is A intersection B, where X belongs to A and X belongs to B. So this is called A intersection B. And in Venn diagram, this intersection is defined as or denoted as the common region. This common region is called intersection of set. The common between A and B. Suppose we have this set A and this set B, then the common region is known as the intersection. Difference is denoted by A difference B, which is X such that X belong to A and X does not belong to B. This is called difference between two sets. And if you want to represent the Venn diagram, the difference A difference B, that region is represented as like this. This region represents R A difference B. This region is A difference B. This is A intersection B, and this region will be, whichever is white, this portion will be B difference A. That means whatever is there in A but not there in B is called the difference. The complement is denoted by A to the power C, which is equal to X such that X belong to U and X does not belong to A. It is A complement and sometimes you represent A dash also. Complement मतलब जो A में नहीं है but universal set में है, that is called complement. Alright. So basically these 4 operations are there, and out of this there are some properties are also there. Like union में you will have properties of commutative, associative, existence of identity, existence of inverse, and so on. And intersection में also there are properties, but difference and complement में, difference में ऐसा property कुछ है नहीं, but complement में yes, there are some properties of complement. Those properties we should know, and whenever we need to prove the set identities, we should use these properties in definition to prove the set identities. Since these properties are very very important, I'll just have a quick review of all the properties of this operation that they have and their application, means wherever they need to apply while proving set identity, we can use those properties if we know them. So here we go ahead. So here we have the properties of union. This is A union B equal to B union A. This is known as commutative property. This is known associative property. This is the existence of identity. This phi is the identity of union, because A union phi equal to A and it could be also written as this is equal to phi union A. The answer is A only. Similarly, A union universal set is universal set only. This is called law of universal set, and A union A is A. This is known as idempotent law. So these are some properties of union. Here is the properties of intersection. This is called commutative property, associative property, law of phi empty set. This is law of universal set. This is distributive law, and this is also distributive law. Like in case of addition and subtraction, addition and multiplication, we see that multiplication is distributive over addition, but here union is distributive over intersection, and intersection is also distributive over union. So these are the properties of intersection. So here are the properties of complement. A complement, whole complement is A. Complement of phi, null set is U. Complement of universal set is again phi. And these two, which are known as De Morgan's law, are very, very important. In fact, this is going to be used in your next class, class 12, and even beyond also. And its proof is also very, very important. You can prove this using algebraic method as well as Venn diagram also, and this proof usually comes in the examination sometimes. So these are the properties of the operations, and of course difference do not have any properties, as I said earlier. So you have to thoroughly know these properties, and while proving the set identities, you should use these properties while proving those identities. That is very, very effective. So this was all about the review of chapter 1. Hope you got benefited by it. Thank you so much.